So we're going to start off with our rectangle. So the base of the rectangle, from where the ball starts to where it lands and hits the ground, I always use a ball as an example, is 115 millimeters in width. So I'll start off with my 0 and 115. The overall height of our parabola is going to be 145. I use 10 as my 0. I measure up 145. We get to there. Now this is going to give us what's called the vertex, which is the peak height of the ball, the travelling ball. And I'm going to label these the same as is in the book, A, B, C and D. And we actually only do all of the work for half of the parabola. The other half is then mirrored, which we're used to doing from the topic of transformation geometry, okay, which we've done in first year. So the distance between DC, I'm going to set my compass up to over halfway. And if you're unsure, just make it that little bit bigger. So I'm bisecting or splitting the line DC into two equal sections. So putting the compass on D, drawing your arc, putting the compass on C, drawing the exact same sized arc, gives you your division line. Now with that division line, I'm going to draw it in orange. And I'm going to continue it on up to the top to give me the vertex. And just for the ease of explanation in this, I'm going to label that as E, the same as the book. Okay, everybody with me on this? Yeah. Now, we're actually only doing the work from the ball starts here, goes up to its peak height. That's it. The other side then, on its return down to the ground, I'll show you a different way to do that, which we should be familiar with. So what we need to do is, the overall height of the path of the ball needs to be split up into equal components, and then DE also has to be split into equal components. So we're going to use what's called the division of lines method. So I am going to draw my own line from A at any angle. I'm also going to use my own measurement, whatever that is, it doesn't matter. And I'm going to split this into 4 or more. So you can choose 4 divisions, 5 divisions, or 6 divisions. Generally we choose 4 or 5. You don't have to do this if that number is easily divisible on a calculator by 4 or 5. And you're looking for round numbers. So you're looking for 10s, 20s, 30s, 15s, 25s, 35s. Does that make sense? If you get 24s, 26s, 27s, don't do it, okay? Because it's too hard to do. So I take this measurement, whatever it is my compass to, and I'm going to go for 5 divisions. Just to have it a little bit different to the book and for increased accuracy. So there's 1, 2, 3, 4, 5 divisions. Now, the point of my last division line, on my own line, I'm then going to bring that to the last point on the line that I need to divide up. So that's my division, that's my 5th division point. That's the last point on the line that I need to divide up. And I'll draw that line. Now, all of the other division lines are going to be parallel to that orange line, and that's key. So I'm going to use my sliding set squares, and I'll bring it along to the next division line, or division point, and draw that in. Bring it along to the next division point, join that up, next division point, join that up, and next division point. Now, the ball starts here on the ground and works its way up, so I'm going to increase these numbers. I'm going to go from 1 to 2 to 3 to 4. I'm going to do the exact same thing from DE. So I'm going to draw my own line from E. I'm going to split it into 5 equal measurements. 1, 2, 3, 4, and 5. I'll bring that point, the last division point from me, 1, 2, 3, 4, 5, to D. And then all the other ones will go parallel to that. Now, key piece of information here is your axis. I'll put this up on YouTube, guys, and throw it into the group, alright? So you can do it for homework, alright? I'll see you tomorrow. Just up there. So these lines will go parallel to the axis. And then the other division lines on the side will go to the vertex. So these will be my purple lines. And just for the ball would start here, so we work away by increasing our numbers. So that would be 1, 2, 3, 4. So it starts there and then we go up to that height, so that's how we increase our numbers. And then for division 1 will go to the vertex. Point 2 on the side will go to the vertex. Point 3 on the side will go to the vertex. And point 4 on the side goes to the vertex. Now all we have to do is where lines 1 and 1 cross, put in your dot, where 2 and 2 cross, put in your dot, 3 and 3 cross, and 4 and 4. And that is our half of our parabolic shape. Okay. To get the other half, we're going to use a simple symmetrical technique and use our compass. And so I'll take point 1, bring it across, for all of my 4 points, I'll bring them across. This axis is the mirror, and whatever distance you are from the mirror, the reflection will be the same on the other side. And that is your shape. Complete.